Hello, everybody. This is Stephen Ramsden, the director of the Charlie Bates Solar Astronomy Project. We're live here from Atlanta, GA, with a very bright night sky in downtown Atlanta. And we're going to be broadcasting the moon for you. We're going to start out first with a Skywatcher ED100 Pro doublet. And that'll show you the full disc. And then we're going to move over to the awesome Celestron C14 Edge HD and get some F-22 images of the moon, which should be incredible. We've got about 2 hours of moon here, and I'll get right to it by sharing what we're looking at now, which is, of course, Lunar. I don't know about you, but I find this to be absolutely fascinating, especially when it's centered on the screen. So this is live moon from Atlanta through a Skywatcher ED100 telescope, and we're filming this with a FLIR, formerly Point Grey Research 6 megapixel camera, and it's just gorgeous. I'm gonna let that sit for a minute or two so you can check it out, and mute my microphone real quick. Okay, so let's name some of the features. I'm not going to bore you to death with too much detail, but everybody wants to know what these large dark areas are, these mare, or seas on the moon. Mare means sea. And back in the old days, people thought these were lakes, water, or oceans or something on the moon, because they didn't have really good Skywatcher USA and Celestron gear, so they couldn't tell what they were. Over here in the upper right portion of this image, there's 5 really dark areas that look smooth, 2 really large ones from the upper left to the center, and then these 3 small ones. Starting with this upper left one here, Mare Serenitatis, which I'm guessing means Sea of Serenity, along with this large crater feature, Poseidonus. And this little one right here, this crater, which is part of the Mare. It's called Crater Lamonier. Crater Lamonier, Poseidonus, the Sea of Serenity. Northern Mare Serenitatis. There you go. Now we'll go to the center one right here, which is the Sea of Tranquility. My friend Steve Kelly wanted me to point out the Sea of Tranquility, and we're going to get a super close-up view of the Sea of Tranquility here shortly in the C-14. But for now, this is a full disk view of it. Lower left corner are 3 almost indistinct craters. Aldrin, Collins, and Armstrong. Guess why they were named that? That's the Apollo landing site, southeast corner of the Sea of Tranquility, right down here. That's right, July 20th, 1969. The Apollo 11 lunar mission actually launched a rocket from Cape Canaveral, a Saturn V, carrying 3 incredibly ballsy dudes in a tinfoil box, hurtled them through space for 3 days, orbited the moon, shot off a little landing module, the Eagle, the LEM, they call it, the lunar module, landed with about 15 seconds of fuel left, right here in the Sea of Tranquility, 1969. The greatest achievement in the history of mankind. And it's a shame we're not living there right now, but that's another story. So three craters over here, Aldrin, Collins, and Armstrong, which are, of course, for Buzz Aldrin, Neil Armstrong, first man on the moon, Michael Collins, who piloted the command module around the moon. Michael Collins was the only way home for these guys, so I'm sure that he is their favorite astronaut, although a lot of the credit goes with Neil Armstrong for his one small step for man, one giant leap for mankind comment. All that happened right here in the Sea of Tranquility. Mare Tranquillatis. You can't talk enough about that. Then we move over here to Mare Crisium, which is this smaller one on the edge of the moon here. Beautiful, beautiful sea on the moon. Mare Crisium. We'll move down a little bit to the one in the center on the edge of the moon, which is, correct me if I'm wrong, Mare Fecunditatis. Thank you very much. Mare Fecunditatis, with the crater Longrinus dominant near the center of the photo. Mare Fecunditatis. These things going by the moon, these are called clouds. It's water vapor in the atmosphere that has condensed into a semi-liquid state because of the dew point and the temperature's proximity to each other. Now let's go for the last Mare, which is right here with this beautiful crater on the left. Mare Nectaris, the Sea of Nectar. Doesn't get any cooler than that. Crater Fracastorius is along its lower rim here. Fracastorius. These two craters, which are beautiful, the one with the center peak and everything, are crater Katharina and crater Piccolomini. Thank you very much. I wish Robert Reeves were here because he's the man. I'm trying to wing it. This super bright feature right down here, which always overexposes on people's photographs. In Imare, Australia, is something I don't know the name of, but it's awesome. So here we go with the first quarter moon live from Atlanta. Cool features on the moon. This is the terminator. People don't talk about this enough. We're almost at first quarter, or what some people call a half moon. There's really no such phase called a half moon. This is first quarter. And this terminator is the actual shadow of the Earth. This is the edge of the Earth's shadow right here. The sun is behind us right now on the other side of the Earth. The Earth's shadow is being cast into space. And the moon is in a position where it is just emerging from the Earth's shadow. So you get this terminator. Notice the curve of the terminator is much more shallow than the curve of the moon. Why? Well, because the Earth's a lot bigger than the moon. So that's the main features, the mare at least. There's a million craters here, which I'll have to get Robert Reeves to talk about, or you can check out my YouTube channel and see last month's broadcast that we had live with Robert Reeves, who described everything in great detail that we're looking at. And it was an incredible time for me to be alive, talking to Robert Reeves about the moon. Again, this part here, this is where Apollo 11 landed. Unfortunately, we're not there right now. It looks like the Chinese are going to get there before us, and I don't care who gets there, but we need to get back up there. So we'll let this sit here for a minute, let you enjoy it. I'm going to mute the microphone. Okay, let me get it recentered. Oops. There we go. Back in the center. Now I'll turn up the gain on the camera, or the gamma, and see if we can get some earth shine in here. Nope. I'm using a Point Grey Grasshopper 6 megapixel camera. And currently a Skywatcher 100 millimeter ED Pro scope. Really, really cool scope. Very inexpensive. You just stick the camera in or the eyepiece in and it works. There's no fuss to deal with it. Giving us a beautiful, beautiful image of the moon this evening. A little bit of turbulence in the air, which is going to cause problems with the C14. But in just a moment, I'm going to switch over to the F11 14-inch Celestron C14 Edge. And we're going to get close-ups like you can't believe with these craters. But notice the movement in the atmosphere that's movement on our atmosphere, of course, because the moon doesn't have an atmosphere. But it's causing the image to kind of pulsate in and out of focus, and that's called seeing conditions. The seeing conditions are not as good as I'd hoped, but you know, these whiny astronomers are always complaining about something, so don't worry about that. It's absolutely beautiful, no matter what the seeing conditions are. It's fantastic. The moon is 230,000 miles away from the Earth. It orbits the Earth every 28 days. The moon rotates every 28 days as well. So we only ever see one side of it because its rotation speed or rotation period is the same as its orbital period, because it's tidally locked to the Earth's gravity. So why do you never see the dark side of the moon? Well, because it rotates at the same speed that it orbits the Earth. Hi, Doug. Welcome. Danya.
Good evening.
We are currently looking at the almost first quarter moon with a Skywatcher Pro 100 millimeter ED scope to get a full disk image. And just a moment ago, we went through all the large mare and talked about some of the features. And welcome my friend Jeff Irick and his family. He's got a beautiful family. They're also watching on our live broadcast. Doug, do you have any comments you'd like to add to the broadcast about the moon, or what inspires you with astronomy or anything like that, or you just want to listen?
Well, it's cloudy here.
That's not very inspiring.
I'd like to open my observatory up, but it's been cloudy here for 6 weeks.
Yeah, we've had some problems with that too. It's really, really cold here right now, and I looked out with my eyes this evening and saw that the atmosphere was very clean. But I live in downtown Atlanta, and it's rare that we see, like right now in the sky, if I look straight up, I can see 1, 2, 3, 4, 5 stars total, and that's about as good as it gets here. Sorry about that. I was saying before I got muted, I live in downtown Atlanta, so I'm surrounded by super bright LED bulbs and houses and tall buildings. And I look up in the sky right now, I can see 5 stars total, which is pretty depressing for me. So it's basically lunar, planetary, and stellar astronomy only from my driveway. I mean, solar astronomy only. Anyway, this is our lovely moon. I was just pointing out the Apollo 11 landing site and what a great accomplishment that was for men. Me and Doug remember when that happened because we were alive back then, but a lot of our viewers were not alive when men landed on the moon. Unfortunately, we're hoping that comes back again. So I'm going to switch over to the C14 now very quickly, and it'll take me a few seconds to get it focused. So I'm going to mute the microphone. And switch it over. Everybody please stand by. Just should be a minute or so. Okay, so here we are in the C-14. I've tried to get the terminator correct, but we'll see. I try to always have a north-south orientation so that people can get what they're seeing. In fact, you can just go outside and look up right now if you're not where Doug lives and it's cloudy. But you can compare what you're seeing here with what you see on the surface of the moon, because I'm looking right at it and I'm orienting my scope, orientating my scope based on what I see visually. So let's scroll down the terminator a bit. A beautiful image here of the mare with the long name that I can't pronounce properly. The sea of some unpronounceable thing. Okay. And let me work on the focus a little bit, if possible. Lots of cool features here. Notice all the shadows, you know, a lot of the simple things people overlook when they're talking about the moon. The shadows in all these craters are making their own little terminator for sunrise and sunset. So if we were living in this crater like we should be, it would be still dark here. You'd be watching a beautiful sunrise come over the edge of this crater if you were looking east on the moon. Very, very, very slow sunrise. Taking a couple of days or several hours at least to come over the ridge of this crater. Of course, this is a nice smooth area of lava flow, millions of years old, with a couple of crater pot marks in it. And then here's some more beautiful craters. This line of expelled debris is from the crater that's up here out of view. When a rock or asteroid or whatever hit the moon that caused this gigantic crater up here spewed debris in all directions. And these rays still exist. They're a little different color because they were churned up after the lava flow. Thank you, Danya. I appreciate you watching. And Madison Irick, you and Adam should be living here before you get my age, hopefully. So let me take a photograph of this, and then we'll move on to a little bit lower portions on the moon. I'm planning on putting a Barlow lens on the camera in a moment and getting twice as much magnification, and we'll see how that works out shortly. Let's find a really cool feature first, and then we'll choose what we're going to look at up close. Well, I'm not sure what's causing the echo that some people are hearing. I apologize for it. I don't really have anything good to say anyway, so you can just turn down your speakers and watch the show if you want. Let's scroll down a little bit further to the Sea of Tranquility, which is in the center of the screen now. This feature always makes me sad and makes me happy when I see it, because this is the place where the Apollo 11 astronauts landed and walked on the moon for the first time. Adam Myrick, you better behave, son. Yeah, the Sea of Tranquility with the craters Aldrin, Armstrong, and Collins is the place where it all happened in 1969 when the Apollo 11 astronauts first stepped on the moon. There's no way to relay that story properly. It's like taking a picture of a sunset. It's just impossible to take a photograph or paint the sunset. It's just so unbelievable. There's no way to mimic it with any kind of technology. You have to see it yourself. So to me, that's the same thing with the Apollo 11 mission. There's no way to adequately relay to someone how it felt to walk on the moon. I'm sure those guys, Armstrong when he was alive, and Buzz and Michael Collins are probably frustrated as they can be trying to relay to someone, you know, when they say, what was it like to step on the moon? It's impossible to explain. Unfortunately, we're not living on the moon right now, which we should be, but hopefully that'll happen in these kids' lifetime now. Madison and Adam Myrick, who are listening in, maybe they'll celebrate their 50th birthday in the Sea of Tranquility. I hope so. Maybe even Mars. That would be even better. So this is it. These craters are all formed by objects in the solar system that have hit the surface of the moon. Some of them have central peaks like this one here, which is a rebound of the crater impact. A very common feature if you simulate a crater in high school or in college and watch what happens when it strikes. It makes this big, large depression, and then the inside highest pressure point in the crater will also rebound back out and sometimes make a central peak. So that's what you get. Sea of Tranquility. Mare Tranquillatis. And no, you can't zoom in close enough to see the remaining leftover parts of any of the Apollo missions, because the maximum magnification from the Earth's atmosphere is about 450x, and it would take about 1500x to see those things because they're so small. The Chinese rover that's on the moon now could easily see them, and our Lunar Reconnaissance Orbiter has sent back hundreds of photographs of the landing sites and the rover tracks, etc. We don't talk about fake moon landing conspiracies in this organization because we are educated. So there's the Sea of Tranquility. Holy cow. It's just gorgeous. I mean, you can't look at it enough, in my opinion. Look at that. Those just tuning in, this broadcast is coming to you live from Atlanta, Georgia. My name is Stephen Ramsden, and I'm the founder and director of the Charlie Bates Solar Astronomy Project. Our Facebook group by the same name exists to get young people interested in science and get us back to the moon and on to Mars. That's our purpose. We educate students and the general public through outreach events all over the world. We're in 27 countries currently. We do a great deal of work in the U.S. with Roger Kennedy and the Timmy Telescope Project out in New Mexico. We got Kevin Lagore, Brent Phillips out Focus Astronomy in Arizona, California. And we got Big Jupiter Joe's Sidewalk Astronomy up in New York. We've got Kuiper Cat up in New York. We try to help these people share astronomy because it's an incredible thing. And if you can get a kid to a telescope, or even an adult, if you can get them to a telescope and make them look, they love it. It works the same way it worked on all us old folks back in the 60s when we would look at Saturn for the first time or something like that. It still has the same effect on people when they look through scopes. I can't tell you how many times I've seen people's jaws drop when they see a solar flare or the rings of Saturn or something like that. The problem is there's about 50,000 different things that keep people from getting to a telescope now. The main one is bling bling and the need to make money, which is the biggest thing in the U.S. Where's my money? We try to teach science without all that mess, free of charge to everyone. I'm going to mute the microphone again. I got a neighbor coming up. So that's my neighbor George. Came out. He's always interested in astronomy with us. And we're back now. We're going to move down the Terminator a little bit and see some other features. This is a great example of a crater with a central peak right here. In fact, multiple central peaks. And these peaks happen because when the crater, or when the rock asteroid hits the moon's surface, the explosion is so violent that the central part of the crater rebounds back up and forms these central peaks. And as you can see, the moon's surface is littered with thousands and thousands of craters. There's no atmosphere or magnetic field to protect the moon or to erode the craters. So a rock may have hit it 20 million years ago, and there's no erosion because there's no wind, there's no water, nothing. So it just stays there. So what you have is a landscape caused by millions of meteor impacts, throwing debris onto each other and making rims. Some of them even land inside of existing craters. And these things here, these little rays of material, are caused by meteors or asteroids landing on the moon and spraying out material in every direction. In fact, you should be able to see a pretty good example of that. Down here, all this white material is newer material that was ejected on top of the existing material on the moon. So it's a little bit brighter in color, reflecting more sunlight. And then come over here, and these craters are all partially in the dark. Like I was saying earlier in the broadcast, I think it's pretty cool if we were living here. We could see a very, very slow sunrise. Let's say you were standing inside this crater right on this edge of this dark line. If you were looking east, you'd see the sun just peeking over this crater. And it would be an extremely slow sunrise. Take several hours, maybe days, for the sun to get up above the crater, the rim wall of the crater, because the moon rotates once every 28 days and also orbits the Earth once every 28 days. So the sunrises are very, very, very slow on the moon. So you could drink all night and never have to go home. So I'm going to mute the microphone again, and we'll just look at this for a few minutes. Okay, here we go. We're back. And that was my neighbor George and his fiancee Cheryl with their dog Buster. They came over to check it out. So nothing personal to you guys, but in-person outreach is always my priority. So I gave them a little talking to you and let them look through the other scope and things. Hopefully we didn't vibrate it too much for you. So let's move back up and look at some more features. And I'm not good with the names of these things. My buddy Robert Reeves knows everything about the moon, but I don't know the names, but I do know the features. And this is an incredibly cool feature that has always amazed me. It's a mountain range. You can see the side of the mountain has got more sunlight and it's brighter. And then there's these peaks and it goes over to a crest here. Of course, there's meteors everywhere. I really, really like this feature. Maybe one of you guys know what the name of it is. I don't care, but it's a very cool feature, and I always look for it when I'm looking at the moon. One of the big differences between the moon and the sun for me, because I'm a solar astronomer, is the moon always stays the same. There's not a whole lot of activity going on up there. The sun, every time you look at it, it's completely different. There's different features. In fact, the entire surface, or what we call the surface of the sun, recreates itself about every 3 to 5 minutes because of convective currents and modeling granulation, super granulation on the sun's surface. So it's never the same, no matter if you look at it 10 minutes later, it's different. With the moon, this is exactly the same moon that I looked at when I was 10 years old. Mare Nectare. Very good. Thank you so much. The Sea of Nectar. But this is the same moon I looked at 10 years old with my first telescope that my mom bought me from the Sears catalog. And it looks exactly the same right now. This is the same exact moon that Danya and Doug and everyone else listening can see outside their homes right now if it's not cloudy. It just doesn't change. Things are constantly showering the moon, small meteors and stuff like that, but it's nothing. Nothing really changes. So it's old faithful for observing. You can always find the same features and check them out and talk about them. That's why they all have names. I mean, nothing's named on the sun because it doesn't last more than a few days or a couple of weeks. We don't name solar flares Flare Ramsden because Flare Ramsden would not be there about 10 minutes later. Which brings up a great point. There are 3 features on the moon named after my great-great-great-great-great-great-grandfather, Jesse Ramsden. There's the Ramsden Rift and the Ramsden Crater and the Ramsden something else. They're not visible right now, but we do have a Ramsden presence on the moon. That's no big deal, though, since there's about 1 million different features. That's kind of like having a street named after you and your name is Smith. You know, big deal. So this is Mare Nectaris, and some interesting cratered features are surrounding it. Let's move around a little bit. Do a flyby. Oops. Back to the Sea of Tranquility. Here's over there on the rim. And the rim of the moon is a good indicator of how bad the seeing conditions are. And as you can see, the rim is pulsating constantly and vibrating, going in and out of focus. The seeing is not as good as I would like it to be. We're currently at f11 in a C14. So we're got some pretty high magnification going already, and we're paying the price for it by not having crisp features. But I'll tell you what, it's better than sitting inside any day of the week. Let's move up. This little crater always bugs me because it's always overexposed. This rim has got a really apparent sunlight reflection on it. It's always the brightest feature on the moon. So whenever I'm adjusting my exposure, this thing is always overexposed. And I'll show you, I'll turn on the saturation indicator. There it is. It's overexposed. And if I turn it down to where that's not overexposed, everything else is underexposed. So dang it, I wish somebody would go up there and spray some gray paint on that thing and knock it down a little bit. But we'll go ahead and take an image here anyway. Maybe they could just put a tarp over it for a while. Of course, that'd be about a 20-mile, 80-mile wide tarp. Take a couple more movements and then I'll stick on the 2x Barlow and see if we can get anything to focus. The seeing may not support that, but we'll give it a shot anyway. And this is a monochrome camera, by the way, shooting 7 frames per second. But even if it were a color camera, it would pretty much look the same, except shooting from downtown Atlanta, it would be yellow because of the pollution in the sky and the city lights everywhere. So you're not missing anything by using a monochrome camera on the moon. That was a jet contrail that just drifted by. Sometimes you get to see jets or satellites pass in front of the moon. It's pretty cool, although it'll scare the crap out of you if you don't expect it. Maybe that'll happen this evening. And that big feature on the right, that C, is the Mare blah 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 that I can't pronounce. And the Sea of Tranquility on the left. Okay, so that run is finished. Let's move up a little bit further on the limb. Wow, that's a cool looking crater right there. I don't think that crater gets enough love. I like it. Oops. Oops. All right. All right. I like that one. Let's put the exposure back up a little bit. There we go. Man, that is a beautiful landscape on the moon. This crater has another small crater inside of it. This crater's rim is partially flattened. Super cool stuff. Take an imaging run there too. I'm going to mute the microphone for a couple of minutes. Okay. All right, so I'm told that the echo may have disappeared on the audio, and I apologize for that. I'm always astounded that I broadcast something live and someone in Australia is watching it live, someone in Portugal is watching live from my little driveway in Atlanta. So I'm pretty happy with the technology. If I have to put up with a couple of echoes now and then or a little pixelated video, then I say it's well worth it. So we're going to take a couple images of this area, and then I'll put the 2x Barlow on so we can see if we can get it focused. Okay, everybody stand by while I put the 2X Barlow on. Sea of Tranquility at F22 with the craters Aldrin, Armstrong, and Collins prominently featured. Melancholy, somewhat. Okay, so take a couple of imaging runs here. And if you want, I can switch back to the full disk view when we're done here. I've got about 30 minutes left before the moon passes behind the local high-rise building. That was a gust of wind that came along and is blowing the telescope a little bit. This giant Celestron C14 Edge acts like a huge sail if there's a wind, especially with the dew shield on it. So a little bit of a breeze can cause it to shake a good bit. That's where the Apollo 11 mission landed. Our local trumpet playing homeless guy is currently on the street playing the same Beyonce song that he plays every night. All right, let's move on down a little bit. Oh my God, look at that. Holy cow. Yeah, there's some dust on the camera. I know. Wow. We got about a steady 7 or 8 knot wind right now, so it's playing havoc with the C-14. But it's still pretty cool. You get the idea. Oops. Yeah, that is cool, man. Me likey. For those that may be just joining, we're using a Celestron C14 Edge HD with a 2x Barlow and a point gray Grasshopper 6 megapixel monochrome camera to look at the moon. We're currently operating at f/22, which means that the telescope, if this were the old days, it has a 14-inch aperture. Multiply that by 22, which would give you 298 inches of tube length. So 300-inch tube, about a 20-foot long tube, I think, and a 14-inch lens. So I'm feeling like Tycho Brahe here with this giant telescope. Fortunately, the Schmidt-Cassegrain design allows that to be folded 3 times. So the telescope's about 3.5 feet long. My numbers could be off, but you get the idea. Funny to me, there's been about 15 or 20 people that have walked by, looked up here, and just kept walking. I don't understand that, because I don't ever force outreach on anybody, but how you can walk by. I mean, this is a massive setup out here. I've got a Astrophysics AP 1200 mount, 2 giant telescopes on it, a 27-inch iMac. I am as friendly as you can possibly be, and yet people walk by here and don't even care what's going on. To me, that's astounding. If I'd seen this when I was a kid, I would have been camping out here the rest of the night. I'd have been moving in with whoever had this telescope out here. Things have changed. People stare at their phones all day and never look up. No one says hello anymore. Everyone's scared of each other because of the news media. It's really a sad state. But you can change that by going out in the public and just talking to people and smiling and saying hello. Especially if you've got a telescope, you can set it up outside, and it doesn't matter where you do it, anywhere. And, you know, invite people over to check it out. Because I guarantee you, if you can get somebody at an eyepiece of a telescope, their walls will fall and they will start talking, and you will learn something you didn't know. And people are always saying, oh, you teach so many people about astronomy. Well, those people are really teaching me about life. I get more out of it than they do. I'm convinced of that. Man, I wish I was just in a lunar rover with an endless supply of water, oxygen, and food and gas, and was driving around these features right now. My wife's always upset because, you know, I volunteered for the Mars mission, and I'm too old and fat, of course, but she's like, you mean you would go to Mars on a one-way trip? It's like, are you kidding? Yes, I would immediately pack my bags and hit the road if they offered me a trip to Mars, even if it was one way, with almost certain death, which it will be. You wouldn't finish that sentence before I'd be in that capsule ready to go. Okay, I'll switch it back to the full screen, and we'll check that out just before the sun leaves my field of view. The moon, I mean, I'm sorry. I'm so used to saying the sun all the time. See what that looks like. Trumpet Man has not been practicing very much. His trumpet playing abilities are still poor, but loud. His volume is excellent, but his technique is terrible. Oops. Talk about a blood moon. Let's see here. All right, see if I can get that focus a little better. If I can reach it. The focuser is about 5 feet away. Let's see. Oh, yeah. There we go. That's perfectly focused. That's looking good. The seeing conditions have improved greatly. At least for a brief period. But folks, that's what it's all about. That is a beautiful, beautiful image of La Luna. Oh my God, that's just inspirational to me. I hope you're enjoying this as much as I am. Wow. Lunar image does not get any better than that, folks. I'm going to mute the microphone and just stare at it. You know, I was thinking about turning the telescope over to a star and just looking at a star. And I looked up, and I live in Atlanta, and there is a total, in my entire sky, there is a total of 3 stars visible. 3 stars. I can see Vega, Arcturus, and I don't know the name of the other one. But it's absolutely, oh, I'm sorry, 4 stars, because I can see the North Star also, Polaris. That's absolutely disgraceful that we've ruined our night skies so much that we can't see anything. These LED lights that they've installed all over my neighborhood, while they may add to safety, they have certainly destroyed the night sky. Stay tuned though, in the coming months, maybe 2 months from now, the Orion constellation will be front and center from my view, and I can get the Orion Nebula and possibly the Flame Nebula, definitely Betelgeuse and Rigel. I can get images of those from here for live broadcasting. And I'm currently working on a setup from Starlight Express and a Hyperstar system for the C14, which will give me an f1.8 scope, 1.9. And supposedly I'll be able to take deep sky images here. I'm going to add a filter that just gives me narrowband hydrogen alpha, I believe O3, and something in the blue region. And supposedly it'll cut out light pollution. It'll take much longer exposures, of course, but the software that Starlight Express has, called Starlight Live, will stack these images on the fly and allow me to broadcast pretty good images of nebula and distant galaxies and things, even from my downtown area. You can image from here, but it takes, 10 times the exposure length, and you must use a narrowband filter because you have to block out all the light pollution. And that'll be coming up as soon as I can figure out how to get it all to work together. I'm one of those rare astronomers that only uses Mac computers. So anything you do in astronomy takes 100 times longer and 10 times the money, because nobody makes software, reliable software for a Mac for astronomy for some reason. And that's in the US, because nothing against old white guys, because I am one, but pretty much everything is based on Microsoft Windows. And nobody wants to give up their ancient computer systems and go to something modern like Linux or Mac. So it's extremely difficult to do deep sky imaging on a Mac. But I have some friends that are trying to fix that. Richard Wright over at Software Bisque has written a lot of Mac software, and we're currently working on something that will allow me to live broadcast deep sky objects, which we should be doing soon, hopefully. So there you go. That's the end of my broadcast, and I'm grateful for those of you that tuned in. Thank you, Doug and Danya, for taking part. And the Iric family, you can now go to sleep. I would suggest watching some Star Trek before you do. And Jeff, me and you need to go birding in the morning. Steve Kelly and my friends in the UK, Tunisia, Kosovo, thanks for tuning in. Good night, everybody.